Good afternoon, ladies and gentlemen, and welcome back to a hazy Bissau, capital of Guinea-Bissau, and we're heading to Guinea. It's not complicated at all. But yeah, welcome back to Flawless 195. I'm Captain Wilson, and this is flight 80 of 210. Come on, halfway mark is in reach. Another 25 flights or so. But flight 80 feels like a bit of a milestone. Yeah, this is a flight going southeast along the Western African coast. And again, another short one, half an hour flight is predicted for this one in cities. It's Bissau to Conakry, I'd a guess for that pronunciation. But yeah, departure time is going to be 4:30 p.m. local time. So we've got about 2 hours of daylight, so plenty of daylight to get us there. Like I say, half an hour, so we might just get up to about, 30,000 feet, level it out, and then be coming back down again. Got another little documentary lined up. It's documentary season out here, if you haven't noticed. Gets us over in half an hour. Like I say, local time, an hour behind the UK, so it is currently 4:20 in the afternoon. I'll prepare the plane for departure. If you have any questions regarding the Flawless 195 World Tour, please do get your comment in the section below. And if you are a new viewer and this video's randomly popped up on your feed, please do watch the route explainer video. The intro says it all as well, but if you want a general idea of where we are and where we're going, we are in the African leg of the World Tour. All 195 countries, all 195 capital cities without crashing. It's a flawless 195 World Tour. And so far, so good. We've had a few, I'd probably say out of the 80 flights, there's been about a dozen really close calls where it could have ended at any given moment. There has been a few dodgy landings, a few dodgy mishaps here and there, but on the whole, it's been nice. The African leg, touch wood, the African leg as a whole has been pretty scot-free. I've been ignoring ILS, been making my own sort of final descent in, and is the case today as well. I'm making my own route, but we don't have to go majorly off the flight path on final descent. It's just kind of a little bit of a slight deviation when we get down to about 7,000 feet, going down to 3,000 feet. I'll deviate off the flight plan a little bit, but should be no big dramas. Like I say, these flights as well are at sea level, so there's no mountainous sort of situation going on. We're along the coastline of Africa, along the western coast, and yeah, like I say, a lot of smaller countries all sandwiched in along the coast. So we're literally just hopping from one to the other. 20-minute flights, half an hour flights, 15-minute flights, 20-minute flights. I think the next one after this is half the distance, so the next one's going to be like a quarter an hour flight after this. Probably do that tomorrow. But yeah, welcome to Flawless 195. Welcome to flight 80. That's enough waffling. Let's get the pre-flight announcement on, and let's get the plane set up, and let's get out of here. A hazy Guinea-Bissau again greets us. The visibility coming in was one of the worst so far, especially in the daylight visibility was one of the worst ones we've had. But got it down, relied on the VFR map getting us in. But this should be once we get a few thousand feet in the air, it should be clear. And yeah, just a hop across the border, Guinea-Bissau to Guinea-Bissau to Conakry in capital cities. Half an hour. Here we go, and I'll get a little documentary on. It's going to blow your mind. It's going to blow your mind, so stay tuned. Stay tuned. Let's do it.
Please pay attention to illuminated signs and crew instructions, including the following safety procedures. The safety card found in your seat pocket contains important information about exit routes, oxygen masks, life jackets, and the brace position that you must adopt if you hear brace, brace. There are 8 emergency exits on this aircraft. The cabin crew are now pointing out the exits nearest to you. Please be aware that your nearest usable exit may be behind you. Emergency lighting will guide you to an exit. In an emergency, leave all baggage on board. Your seatbelt is fastened, adjusted, and released as shown. It must be fastened when the seatbelt signs are on, and we recommend that you keep it fastened at all times. If the air supply fails, masks will drop from above you. Pull a mask towards you to start the oxygen. Put the mask over your nose and mouth and breathe normally. Hold the mask in place with the strap. Pull on each side to adjust. Put on your own mask before helping others. If we land on water, take a life jacket from under your seat. Remove from the pouch and put it over your head. Pass the tapes around your waist and click together. Pull the strap to adjust. Do not inflate it inside the aircraft. When outside, inflate it by pulling the toggle. If it fails to inflate or needs topping up, blow into this tube. There is a light and whistle for attracting attention. The cabin crew can assist you with life jackets for children. Your tray table must now be stowed, armrests down, window blinds open, and seatbelt fastened. Further information regarding your safety on board can be found in the in-flight magazine. We hope you have a great flight.
I'm going to turn all the planets in our galaxy that could have alien life into marbles and put them in here, the Colosseum in Rome, to give an idea of just how many planets could be like Earth, that could have alien life. Then I'm going to show you how one of these blue marbles, a planet that we found recently, might actually have alien life on it, how we found it, how we might confirm it, and where else we might find life. We live in a pretty flat galaxy called the Milky Way. If I scale it to 100 meters across, covering the Colosseum's arena where the gladiators fought, it would only be about 1 meter thick where we are. There are at least 100 billion stars in here. If I make them all bright enough to see, it just looks like a cloud. So let's simplify the galaxy. Let's make it a flat map and focus on the exciting part, the blue marbles. Every blue marble I put in here represents a habitable planet. These are small rocky planets like Earth that are the right distance from their star to be the right temperature for liquid water, the important thing life on Earth needs. Here's blue marble number 1, Earth. The only planet in our solar system in the habitable zone. Obviously,
Cabin
it's
crew
not to
seats for
scale here.
takeoff.
We're just making these planets a size we can see, like a pin on a map. Exoplanets, that's planets beyond our solar system, are incredibly difficult to find. Imagine trying to spot a speck of dust in the air at night near a candle 20 miles away. If I made this video in 2010, I could show you all the exoplanets we'd found, around 400. You'll notice they're close to Earth and big. That's all we could detect. I haven't made them marbles as they're big gas giants like Jupiter, not small rocky ones like Earth. So none of these were candidates for being habitable exoplanets. They were just big enough to wobble the star they orbited. That's how we found them. In terms of blue marbles, 15 years ago, we still only knew of one, Earth. Then everything changed. The Kepler Space Telescope launched. It didn't look for wobbling stars, it looked for blinking stars. More accurately, it looked for regular dips in brightness caused by planets passing in front of these stars. This is called the transit method. It's like when a bird flies in front of the sun, momentarily blocking it. But it's a terrible way to find planets, isn't it? For the same reason, we hardly ever notice a bird flying in front of the sun. It's much more likely to not fly in front of the sun, just like it's much more likely for a planet's orbit to not line up exactly with us. If you were at a random point in the galaxy looking at the sun, the odds that Earth would line up with it and dim it every 365 days would be less than 1%, and it would only dim the sun by 0.008%. You'd need to watch it for more than 2 years to make sure it was a planet that was regularly orbiting. To detect Neptune, a planet that takes 170 years to go around the sun, you'd need to observe the sun for more than 340 years to confirm Neptune was there. So again, this is a terrible way to find exoplanets. It's a miracle Kepler found any, and yet in a tiny section of the galaxy, it found thousands of them. In fact, it found something totally unexpected. Kepler found out there are more planets than stars out there. We used to think exoplanets might be quite rare and the solar system really unusual. Kepler took us from, we're not sure if there are many planets out there, to, oh, there are hundreds of billions of planets per galaxy. But that wasn't the most exciting part. We learned that almost 1 in 2 stars near us has a rocky exoplanet in the habitable zone, a potential blue marble, around almost 1 in 2 stars. Personally, that's completely changed how I look at the night sky. Kepler discovered there are around 40 billion rocky exoplanets in the habitable zone in our galaxy alone. 40 billion planets with the potential for life. And that's why we're here. Big numbers don't mean much to me. So let's actually see how many potential Earths there might be in just our galaxy. Just a reminder here that the Colosseum represents just one galaxy, and there are lots of galaxies out there. It's a little difficult to process just how many potential Earths we have filling up this space. I'm showing it here in its original full size, but despite being almost 2,000 years old, the Colosseum is still the largest amphitheatre in the world. It's twice the volume of Madison Square Gardens, and we believe it could seat up to 80,000 people. That's similar to a large football stadium like Wembley Stadium in the UK or the Rose Bowl in the US. And yet, the marbles keep filling it up. I've added the Statue of Liberty from the feet up to help give an extra sense of scale. Now, if you hadn't guessed already, you can indeed fill the Colosseum with blue marbles representing potential Earths in our galaxy. Each one of these is a rocky planet in the habitable zone. This is what 40 billion looks like, and it's pretty overwhelming for the ramifications for whether there's alien life out there. But let's take this a step further. Let's shrink down the Colosseum of planets to the size of a peppercorn it now fits snugly inside a single piece of cereal. In my last video, I turned all the galaxies in the observable universe into pieces of cereal and poured them into a swimming pool. Each of these galaxies, each piece of cereal, contains its own micro-Colosseum, packed with billions of potential Earth-like planets. And I can now complete the shot I started in my last video. We live on this rocky planet in the habitable zone. Earth, our blue marble, among the billions of other marbles in our galaxy. Our arena of wonder, the Milky Way. Just one piece of cereal in an observable universe with enough pieces of cereal or galaxies to fill up 355 standard size swimming pools. I'm never going to be able to fully grasp this kind of scale. I don't think anyone can, but I think this is the closest I can get to explaining these numbers in a way that makes sense to me and is something I can remember. This perspective can feel overwhelming, but the more I think about it, the more it actually fills me with awe and hope. Even if humans are around in a million years, and even if many of these galaxies are unreachable to us, we still couldn't put a dent in visiting all of these worlds. If we wanted to, our future will always be full of adventure and exploration out in space. And of course, there could be so much alien life out there for us to find. But this isn't the whole picture, and I might just surprise you with why it's not. Firstly, we need to be sensible and look at counter-arguments to these numbers, filters that reduce these opportunities. Earth has a strong magnetosphere, protecting us from solar storms and keeping our atmosphere intact. Without it, life like ours wouldn't exist. This is what we think happened to Mars. It used to have an atmosphere and rivers of water, but because it only had a weak magnetosphere that eventually stopped, the sun's solar storms stripped its atmosphere away. How many of these marbles have the same protection Earth does? Probably quite a few, actually. Magnetospheres aren't unusual in our own solar system. Many of our planets have them, though it's mostly the larger ones. There are other filters we can apply to these numbers. 70% of these marbles orbit closely to cooler, more erratic stars than our sun, called red dwarfs. Volcanoes, atmospheres, plate tectonics, chemical compositions, there are lots of variables that can affect the probability of life like ours thriving. The more we can understand about exoplanets and the planets in our solar system, the more we can adjust these numbers down. But that's what we hear about most, isn't it? I think we have a slight bias that we feel these numbers should be smaller. We hear about all the variables that might make life less likely. Something that isn't discussed as much is adjusting these numbers up. What if this pile of worlds that might have alien life is too small? It makes sense that we look for rocky planets in the habitable zone because that's like Earth. We have lots of life. We have liquid water, pretty much the only thing life needs. But I mentioned Mars a second ago having water, didn't I? We think it had rivers of water for more than 1 billion years. Mars has never been in the habitable zone, so wouldn't pass the checklist to get into this pile. It was only warm enough because of a thick atmosphere and lots of volcanic activity. So we need to take planets away from this pile because they have the wrong atmosphere and the wrong amount of volcanic activity. But then we also have to add planets to this pile because they have the right atmosphere and the right amount of volcanic activity, even if they're not in the habitable zone. Europa, Jupiter's ice moon, we think has more liquid water than all the oceans of Earth put together. It should be much too cold, but it's heated by something called tidal forces. This is when Jupiter's gravity squashes and stretches the moon as it comes closer and further away, like squeezing something in your hand can warm it up. Other moons that might have liquid water include Enceladus, Ganymede, Titan, Callisto, Triton, Mimas, and even dwarf planets like Ceres and Pluto. Mars may still have some underground water too. That's 10 possible locations for liquid water in our solar system, and 7 of those are moons. Each has its own challenges. For instance, Jupiter's strong magnetosphere can reach out and protect Europa from the solar winds of the sun, but the same magnetosphere powers even more harmful radiation of its own that might get through its icy shell. Each moon is quite different, but that's perfect. Variety means opportunity, and none of these 10 worlds are in the habitable zone. None of them would make it into this pile of marbles. It feels like for every good argument to make this pile smaller, there's a good argument to make it bigger. So, if there is life out there, we might be more likely to find it on a moon, not a planet. And the numbers are even more astonishing for moons. There are hundreds of moons in our solar system, and exomoons probably greatly outnumber exoplanets too. Because of tidal heating, none of them need to be in the habitable zone to have liquid water. So while there may be 40 billion rocky planets of opportunity for water and life in our galaxy, there could be hundreds of billions of moons of opportunity to add to this. There's also another problem with trying to make these numbers smaller. These numbers assume something that makes sense, but isn't very logical. They assume alien life is just like Earth life. We have to do that as life on Earth is the only life we know of. It's the only data we have. But alien life could be silicon, not carbon-based, or exist in an environment we wouldn't expect. It will have had a completely different history of natural selection in a very different environment. It might not need water. In 2020, phosphine was possibly detected in Venus's atmosphere, something that probably can't happen naturally. On Earth, it's created by large amounts of microbial life. The surface of Venus is ridiculously hot, but high up in the atmosphere, the temperature and pressure are actually similar to Earth. But if there is alien life in Venus's atmosphere, it would have to thrive on sulfuric acid instead of water. But that might actually be possible. NASA hopes to send the Da Vinci probe to Venus's atmosphere in a few years to confirm whether there is alien life there. The mission has been delayed due to budget constraints and is even in jeopardy of being cancelled. Life on Earth, life that we understand really well, has constantly surprised us over the years with its ability to exist in places we didn't think it could. I don't like to use the word definitely much when talking about science, but this I think is one of those times I can. Alien life would definitely be different to ours in where it can survive or thrive, and that only greatly increases the number of planets or moons to add to this pile. Which brings us to the very obvious question. Even if this pile is smaller or bigger, with so many potential worlds, where is all this alien life? Why haven't we seen it, found it, photographed it? Why haven't the advanced ones said hello, invited us over for a cup of tea? This is such an important question, so there are so many.
Okay, so just a quick update from the flight deck. We've come up to 35,000 feet. I'm going to cruise here for the next 5 minutes or so, and then we are going to head down on the descent into Conakry, Guinea. In the next 3 minutes or so, we're going to start the descent because we are just coming up to about 100 miles out from the runway. So if I was at 39,000 feet, I'd be starting the descent any second now. But because we're obviously 4,000 feet lower than that, I have to take that into account So how long it takes us to get from 39,000 to 34 to 35,000 feet is what I'm going to take as a little buffer here of a couple of minutes, and then we will begin our descent down to 7,000. Then we'll have a look, and then we come down to 3,000, and then I'll deviate off the flight path slightly to get us in. But I hope you're enjoying the documentary. But yeah, descent is within the next couple of minutes, and then so expect us to be down on the ground in the next 20 minutes or so. Okay, thank you. Let's carry on this epic spaceman. Let's go.
Ideas and theories about why we haven't found it, the Drake equation, the Fermi paradox, the great filter, the rare earth hypothesis, the zoo hypothesis. There are many more. Lots of interesting ideas, lots of complicated words. It's hard not to guess when the question is so important to us. But I personally think the reality is actually more common sense and doesn't really need the word hypothesis after it. The reason I think we haven't found any alien life yet is we haven't had the power to find it until now. This is best explained with a quick and simple example. We have these huge radio telescopes, right? James Bond had a fight on one of them. We have optical ones too, with mirrors, even some in space. We can see things towards the edge of the observable universe, right? That's all correct. So let's make an imaginary twin Earth, and we won't put it in some distant location away. We will put it the closest possible distance to us, and let's train every powerful telescope we have on it. This is the ludicrously best possible case scenario. Our twin Earth would be going around the closest star to us, Proxima Centauri, a little over 4 light years away. On my map back at the start, Proxima Centauri would be 4 millimeters away from Earth. Because our marbles aren't to scale, they'd literally be fused together. They're so close. Can you even tell this is 2 planets? What level of detail image can we take of this twin Earth? Here. How clearly can we hear their radio transmissions? Can we watch their alien TV broadcast over radio waves? The astonishing answer is we would detect absolutely nothing. Unless they were deliberately trying to send a signal directly at us, we would detect nothing from the closest possible distance to us. Isn't that unexpectedly ridiculous? Our telescopes don't have the power to detect our own random radio signals or take a picture of us if we were the closest possible distance to us. We have all these theories about why we can't see alien life, but we're saying these things while we sit here with our eyes shut. But the great news is we're just starting to squint a little. One of the craziest things I discovered when researching this video is that our imaginary twin Earth going around Proxima Centauri isn't even imaginary. In 2016, we discovered a rocky planet in the habitable zone, very similar in size to Earth, going around Proxima Centauri. We have a twin Earth, the closest possible distance to us. It's called Proxima b. We don't even know if it has an atmosphere yet. It's unlikely to be similar to Earth though, because it orbits closely to its red dwarf star, which might make it difficult for life like ours to exist there. We have so much incredible technology, and science is so good at overcoming problems. So why are we so blind to such an important question? There are different ways to answer that, but I feel like the most accurate answer is slightly awkward to talk about. We haven't been able to look properly for alien life yet, not because of technical limitations, but because, as a society, we spend more money on pet costumes every year than the entire 10-year budget of the Kepler mission that, fundamentally changed our understanding of the universe. I'm not blaming pet costumes. How could I? I'm just saying science, even space science, is underfunded. NASA and other space agencies work wonders with limited funding, despite repeated studies showing that for every $1 spent on NASA, the US economy gains 3. NASA's exciting Dragonfly mission to send a drone to Saturn's moon Titan to look for life had multiple delays over the last few years, trying to get funding. If it was funded when it was first confirmed, it would be halfway there now. Currently, it might launch in 2028, arriving in 2034, or it might not launch at all. As of May 2025, NASA's budget is in danger of being drastically cut, something that would cancel almost every mission involving searching for life. NASA and the Planetary Society have been pushing for a mission to Europa for almost 30 years now, but the Europa Clipper was only launched last year in 2024. Science can work wonders on a shoestring budget, so we assume it always can. But the biggest problems require a bit more string. Perhaps the best example of not using much string is SETI, the Search for Extraterrestrial Intelligence. They use radio telescopes to listen for signals from advanced civilizations. It's one of the easiest, cheapest ways to find alien life. That might sound confusing because I said we couldn't detect life on nearby planets, but the difference is they're listening for deliberate, powerful communications. They haven't found anything yet, apart from one brief, unexplained signal in 1977, but an absence of evidence isn't evidence of absence. This is one of the places many people have expected or hoped to find alien life quickly. But the thing is, we know of only one way a species can become intelligent: self-replication, variation, and a hostile environment. That means any advanced alien species that went through that would almost certainly understand survival and self-preservation. Even if they've become AI or have evolved beyond crude emotions, they'd still recognize that others might not have. This is where it gets a bit dark. If an advanced civilization had technology to travel through space faster than us, it could probably direct an asteroid like a bullet at a planet hundreds of light years away. You might have read or seen that in science fiction, but it's totally reasonable. On a galactic scale, we all kind of live in glass houses with plenty of stones lying around. I think it's unlikely a species would do that, but that vulnerability shouldn't escape any intelligent species. This idea is known as the dark forest hypothesis. Civilizations stay quiet to avoid drawing attention. We call it a hypothesis, but some ideas like checking the strength of ice on a frozen lake before jumping on it are just common sense. And the smarter you are, the more likely you are to have common sense. So any civilization smart enough to send a deliberate signal should also be smart enough to know not to. The only flaw in that argument is that we've done it. We've sent out about 5 deliberate signals. But if we stop now, and I hope we do, those signals are just tiny, weak blips in cosmic time. Even if a million alien civilizations exist in our galaxy, the odds of us listening at the exact moment one makes an early mistake and says hello are very small. But that's why SETI must keep listening, because we just don't know how much advanced life there is, and we could get lucky. The longer we listen, the luckier we might be. But while we listen, we also need to look, and that's the hard part, which brings me to alien life that we might have already found. In 2015, Kepler discovered the rocky exoplanet K2-18b in the habitable zone, using the transit method I talked about earlier, where a planet dims a star as it passes in front of it. This method might be rubbish at finding exoplanets, but it has an incredible side benefit. Imagine someone 2 miles away. On my camera, they're too small to see, smaller than 1 pixel. But if they turn on a bright flashlight, I can see the light. It has the power to light up a pixel of the camera, even if it's smaller than a pixel. Now, if they put a gummy bear in front of the light, I can tell it's red, even though it's way smaller than a pixel. This is exactly what we do with stars and planets. Even though distant stars are just 1 pixel on our telescopes, When a planet passes in front of its star, it's backlit by the star, and the colour of the star will change as some of the light travels through the atmosphere of the planet, just like the red gummy bear. But instead of just looking at its colour, we can look at the full spectrum, and we can see dips in the frequencies where specific atoms and molecules absorb that starlight. So we can actually detect atoms in the atmosphere of K2-18.
Yeah, another quick update from the flight deck. I started the descent too soon. We're way too low here. We should be at probably 25,000. We're probably 10,000 feet too low here. So we're probably going to cruise at 7,000 feet for about 10 minutes, I would assume. Because we're going to get to 7,000 feet before we get to CY 625 and get that turn going. So yeah, we're basically and I shot myself in the foot because I said, "Oh, no mountains, no hilly areas. We're all at sea level. It's all fine." But it is actually a little bit hilly. I don't know if I'd go as far to say mountainous. That might be over egging the pudding. But there are some hills over in inland here. So we don't want to be too low. I've set the plane to settle out, to level out at 7,000 feet, and we're going to hit that pretty soon. And then, it will be 10 minutes at 7,000 feet before then going down to 3,000. And I'll probably deviate once we get to DGOV, once we get to GUV there. I will carry on that trajectory rather than that final turn. I'll then carry on that and head more south, and then come in more southwest to land. If you get south, yeah. But yeah, there'll be a slight deviation of the flight path at the end. But yeah, we're going to be coming under 10,000 feet now. Like I say, we're too low. I could be at 20,000 feet here and not be under any kind of pressure. So yeah, we're a bit too low, but it is what it is. I don't think we're going to hit any mountains. It doesn't look that severe, does it? It's not the Himalayas by any means. So we'll be fine. But it's not, it's not what I want. I want to do this as professionally as possible. Go play the highlights reel of me doing a plethora of ridiculous things. But yeah, no, we're getting on 10,000 feet, so I'll switch the lights on, and like I said, we'll cruise at 7,000 for 10 minutes, and then we'll think about when we get to DEKUV about coming in. But yeah, we're inbound. We're down the ground 10, 15 minutes. All right, thank you.
B, a planet we can't directly see, from 120 light years away. This is such a good example of the power and wonder of science to do the seemingly impossible. And this method is one of our strongest ways of finding alien life. Hubble, and now the James Webb Space Telescope, can see the planet K2-18b probably has water, hydrogen, helium, methane, carbon dioxide, no ammonia, and possibly dimethyl sulfide, or DMS. We only know of one way that could be produced: life. On Earth, DMS is only produced by life, by animals, plants, and bacteria, but most of it by plankton in the ocean. And K2-18b has all the indications and chemistry of being something called a Hycean world, a water world. It really could have a lot of simple alien life on it. To confirm that, we need more data, more observations every 33 days when the planet transits. NASA will remain cautious, I'm sure. Extraordinary claims require extraordinary evidence. And the DMS signature in that signal is weak. It's at the limits of the power of JWST. So I need to quickly interrupt my own video here, because the day after I filmed this video, there was an announcement from a research team looking at the K2-18b data, and they said they were 99.7% sure that K2-18b has DMS. So very strong evidence for alien life. But then 4 weeks later, there was criticism of that from a different team looking at the same data and more, and they felt K2-18b's DMS signal wasn't clear enough and too close to methane to be sure it was there. So, who's right? it's probably best to err on the side of caution for now. The second team believe we need to look at data from 26 transits to have a strong idea either way. So we need about 5 more years of data. So the situation now is we do have tantalizing evidence that this could be alien life. But again, it's at the limits of JWST. But in about 5 years, the ELT, a telescope I'll mention in a second, will be complete. So data from there and more transits from JWST should give us a more definitive answer as to whether there is good evidence for alien life on K2-18b. And just to clarify, K2-18b is one of 3 rocky planets in the habitable zone that we have looked at the atmosphere of. We've looked at just 3 blue marbles among the 40 billion, and one of them is already very exciting. But if we start detecting similar molecules on other planets with JWST and future exciting telescopes like the ELT here, the remarkably named Extremely Large Telescope, we might find stronger signals. We've only just begun analysing exoplanet atmospheres. That is us starting to open our eyes. And as we gather more data, we may uncover surprises about the diversity of worlds around us. If we can't gather enough pieces of the puzzle from there or from the ELT, the HWO, the Habitable Worlds Observatory, the successor to JWST, is hoping to launch in the 2040s. It will be the first telescope primarily built to search for life on other planets. It is an incredibly important telescope. Building bigger telescopes and arrays and missions to moons with water in our solar system seems inevitable, but it's not. It requires money, and that means it requires support and enthusiasm for space and science from the general public. The more we support science, the sooner we will answer the question of whether we're alone. Which takes me to a fact I'm really proud of. This video was sponsored by the Planetary Society, a non-profit founded by the wonderful Carl Sagan. Their mission is to involve their members in the search for life beyond Earth, advancing planetary exploration and helping to defend the planet from asteroids. They genuinely do those things. For instance, they've helped support SETI for 45 years now, and were the driving force behind the Europa Clipper mission happening. In my opinion, the most exciting search for life mission we've ever undertaken. It will arrive at Europa in 2030. They have a worldwide community of 2 million space enthusiasts.
Okay, another quick update. I'm going to take manual control of the plane in the next minute or so because we're going to carry on straight on. Where the plane turns there at GGOV, we're not going to do that. We're going to carry straight on and then turn slightly later into, and that should line us up with the runway nicely. So that is the plan. We'll carry on in this trajectory, so I'll take manual control now, and yeah, should be down the ground next 5 minutes or so. All right, thank you. Hope we've got time for the end of this video, possibly.
And are currently fighting to stop NASA's budget being drastically cut. If you feel we need much more space funding, not much less, then you share their goals. If you're passionate about our search for alien life and humanity's future in space, you can join them and become a member today at planetary.org/spaceman. There's also a link at the top of my description below the video. I'm a member and I'm very happy to be. Nobody knows how much alien life there is out there. We need more data to understand whether this pile is smaller or even bigger. But hopefully this video has helped improve whatever your guess is as to whether there is life out there. All I know is the last 30 years of science has built up this unexpected ocean of statistical opportunity for life that seems too big to evaporate away completely. When trying to guess if there's alien life out there, I try not to let my feelings of hope cloud my judgment, but I think that hope is justified. For me, there is nothing more exciting in the universe right now than the idea of sending a probe to land on Europa or Enceladus. I worked out that this is what the genuine view would be like from Europa. A future mission involves what NASA calls a cryobot, a radioactive robot creating its own heat that would melt its way through the icy crust, taking perhaps 2 years to melt through 20 kilometers of ice, slowly descending into this frozen black abyss until at last it hits water. Its camera and light flicker on, sending video to the surface, revealing the secrets of an alien ocean bigger than anything on Earth. What would we see? As much as it sounds like it, this is not science fiction. This is something that we will probably do. The mission would cost around 1% of the cost of landing people on Mars and bringing them back safely. Getting people on Mars is profound and inspiring, and I'm all for it. But all of these missions, Dragonfly, Da Vinci, this ridiculous cryobot mission to Europa or Enceladus, they all cost 1% of a Mars mission or less. HWO costs about 2%. There are even a few people out there who could personally fund these missions. Imagine if the HWO was cancelled, but then a single person funded it, and it found evidence of alien life. Imagine the person that helped change humanity forever. What a legacy that would be. Maybe Jeff Bezos will see this video one day and feel the same. As for advanced alien civilizations, they're likely far rarer if they exist. It seems likely that most life would be like bacteria, plants, or maybe jellyfish. On Earth, it took 4.5 billion years to evolve an intelligence like ours, so the vast majority of life even here has been very simple. We'd expect to see the same out there. Advanced alien life is going to be harder to find, I think. Not necessarily because it's not there, it just makes sense to me that if it is out there, it would be a cautious explorer. There are so many creatures on Earth that seem alien to us. Can you imagine the variety and strangeness of what might be out there for us to find, evolving in incredibly weird environments? It's no wonder we love sci-fi so much. It's often bizarre fantasy that's entirely possible. I might disappoint some people here with my pragmatic guess, but I don't think any advanced life has visited us. Or if they have, we'd never know. I think we'll probably earn our answer to perhaps the biggest question ever: are we alone? We have forged our ability to start opening our eyes to the galaxy, and we will start to see in an ever-increasing bubble that will soon encompass our neighborhood of planets and stars. To paraphrase some of JFK when he was talking about going to the moon, we choose to explore our universe and understand the worlds out there, not because it's easy, but because it's hard.
Okay, cabin through seats for landing.
Watching my video.
Thank you for watching his video. Right. Messing about with things I shouldn't be messing about with here. Let's turn the game audio up. Let's get it down. It's looking good. It's looking fine. Okay, come on. Okay, doesn't seem too windy. No Storm Amy over here in Guinea. We're a few thousand miles away from Storm Amy, thank God. Look at it. It's just, we're just gliding it, mate. It's like slow motion. Watch this, watch me crash it. Look at it, we're just gliding it in. Absolute glide here. If I don't butter this landing. There's not a breath of wind. I can't go down there. I'm too fast. But that is perfect conditions if I ever saw it. Perfect landing conditions, not a breath of wind. I had the speed down to landing speed, you know, way too early, but it's better to be overcautious than risk it for a biscuit. But yeah, we are down safely. Flight 80 is complete. Let's get down this taxiway here. That'll do us nicely. I'm turning the next taxiway. Do not fret. There we go. Another flight in the bag. Welcome to Bissau Airport, Conakry. Local time is 7 minutes past 5 in the afternoon, and the outside air temperature is 29 degrees. If you have enjoyed flying with us, please do drop me a like on the stream, on the video, and get yourselves on that bell icon to receive all notifications on future flights of this Flawless 195 World Tour. Connecting flight will be to Freetown, Sierra Leone, which is even shorter than this. I reckon it's about half the distance. I saw it when I was setting up this flight. I saw Freetown pop up on the map, and it is literally just a hop over the border. It's literally going to be a quarter of an hour, maybe even less than that, for the next flight to Freetown, Sierra Leone. But thank you. That is all. Documentary about the universe and alien life and how many potential planets there are with alien life on it. Enough to fill a coliseum, and then shrink those coliseums down to the size of a piece of cereal, and then put all those in 32 swimming pools. Oh my goodness me. Yeah, so probably not alone out there. But anyway, I am alone in this endeavour of flying to every single country within Microsoft Flight Simulator. I doubt this has been attempted, and I very much doubt it's actually been done. But yeah, that is Flight 80 in the bag, GGOV to GUCY. GUCY is the airport codes. But we are down. Let's get it parked up. Let's get it parked up and draw a line under the whole affair. I think the flight's ended up a bit longer than the 20 minutes. It might be more like half an hour in the end. But, well, you know, shoot me. It is what it is. Where should we go? Should we go over there? There's even airport gate sort of thing, which I haven't seen for a good few countries. Let's swing around it, and we'll go over that way there. Oh, we've even got a... Oh, are you ready for me? Oh, you're ready for me. Oh, look at that. Oh, you knew I was coming. Oh, lovely. Oh, spot on. You got a spot of tea for me. Oh, you knew I was coming. Oh, lovely, darling. Oh, lovely. Oh, lovely. Look at that. Oh, fantastic, darling. You knew I was coming. Oh, brilliant. Hey, it's not every airport you get this kind of a situation. They're there ready with their bags, ready with everything. Got the bridge ready. Got a man waving us in. Yes, Brevstonian. Yes, lad. I ain't seen no airport staff for the last dozen countries. How we doing, me old fruit? You knew I was coming, didn't you? He knew I was on my way as well. Are you trying to... Well, there's a lot of people booked in for the flight to Sierra Leone, isn't they? Everyone's keen to get to Sierra Leone. The bags are ready to go. I'm not going today, mate. I'm not going today. Yeah, I'm not going today. The sun's going down, you see. I don't do night flights, especially when I don't know the terrain. Are you listening? I don't know. I don't do night flights, Brevston. No, so we'll go tomorrow. So you can take them bags back into the terminal. We're not going yet. Well, I'm not going to Sierra Leone today. You must be mad. It's a setting sun. Anyway, in fact, I could do. Do you know what I mean? I could do it now. Yeah, get over there. But I'm not gonna do it. I'm not gonna do it. Right, that's it. Flight 80 is done. Seatbelt signs are off already. So professionally, right. What do you reckon? It said 20 or 20... No, what did you say? Half an hour, didn't it? Now, what did I say? I said half an hour. It's taken 37 minutes. Yeah, so we're 7 minutes, 49 seconds late on this one. No, I did say half an hour, not 20 minutes. Yeah, it was always going to be half an hour. Went up to 35,000 feet, cruise there for a bit, then down to 7, cruise at 7 for a bit. Yeah. I should have started the descent later. Anyway, do you know what? As I always say, it's not perfect, right? It's not flawless. What I'm on about. But it's flawless in the way that we're not crashing, are we? You know, it might not be the perfect descent and the perfect, you know, the perfect final and the perfect, you know, it's not going to be perfect every time. But are we smashing it into the Atlantic? Are we plunging into the Atlantic? Are we smashing into mountains? Are we doing anything obscene? Are we barrel rolling into... no, we're not, are we? We're in one piece and we're 80 flights deep and it's the 4th of October. I think I started this on the 13th of July and we've not crashed a plane, helicopter, Daha, nothing in 2.5 months. So I'm quite happy with that. Flight 80, Bissau to Conakry is done and dusted in 37 minutes, 49 seconds. I expect the next flight to be half of that. But that is all for today. Thank you for joining, and please do subscribe for the next flight to Sierra Leone. Thank you, and the world tour continues. Come on in.